Hello guys, welcome back to another one of my videos. In this video today, I'm going to show you how to wire and install the DDCS version 4.1 that we introduced on this channel in one of our previous videos. So right here, I've already laid down all the components that I'm going to use for this particular project. This is going to be installed to upgrade our current CNC machine in the lab. We've got a new spindle for this, so we're going to install that. So I've already laid everything down on the panel together. So let me give a brief introduction to all the parts that I'm going to use here. So right here you'll find that we have stepper motor drivers. This is the DM556 stepper motor driver. This is actually very good as it works well. So we have 5 of them, 2 for the Y-axis, 1 for the X-axis, 1 for the Z-axis, and 1 for the A-axis. Since our CNC controller, the DDCS 4.1 had 4 axes, we have the X-axis, we have the Y-axis, we have the Z-axis, and we have the A-axis. So we're going to use 5 drivers to control all the motors for the axis. Right here we have the interface. This is the interface, the thing that connects to the stepper motor, the CNC controller, to the drivers and control all the other peripherals of the project. Right here we have 2 power supplies. I'm just going to use 2 power supplies for this machine because I feel like I can use 2 power supplies for this machine. So right here I'm going to use the 36 volt power supply to power the motors, and then I'm going to use the 24 volt power supply to power the CNC controller. Take note, this CNC controller is 24 volt. If you use 36 volt on this one, you fry it, so be very careful. Right here you have the VFD for the CNC machine, for the spindle that I got for the project. This spindle is a 3.7 kilowatts. It's very big, so I got the Fuling inverter for this one. The series for this one is the DZB series, and the reference number is, as you can see right there, the reference number is right here. So for the power side, I use a contactor to make a holding switch to power the CNC, the system. Right here you have a circuit breaker, and right here you have a contactor to make the holding possible. So let's wire the holding switch. So what is a holding switch? A holding switch consists of a contactor and 2 push buttons, where if I press this button to start, it will send power to the controller, and then if I press the red button, it stops. So to do that, we need a contactor, and this breaker here is just for extra protection. So let's do that. So we're going to start by connecting the normally closed button at the output of the breaker. So the contactor has a coil. This coil is going to energize the mechanical switch inside this, and then it will press in. So we're going to send power to the coil. But before we do that, we need to pass in again the normally open switch. Okay, so they are connected in series, as you can see right there. The other side now will go to the coil. Okay, so we have these 2 connected together, so we're now going to send this other part to the coil. Let's send it to A1. Then the other side of the contactor goes to the ground. Okay, so we've wired this part already. We send it to the to the ground of the breaker. So we have that. Now we're going to connect our auxiliary switch with the normally open switch, so this one here. So we just open back this one here. And connect together with this one. And send back in place. Let's send it to the auxiliary switch of the contactor. Okay, so we have this part connected, so we have now the other part sent to this one. So we are done with the holding switch connection. So let's test this. You see that if I press the green button, the contactor will trip. If I release it, it closes. Trip, closes. You can see that here. So this is power on, and this is power off. Power on, power off. And at this point, if I can turn it off with the breaker, current does not go through. But if I press, bring it back up, I press, and there you have it for the first part, connecting the power switch to the system. So now we need to distribute power to the whole system. So let us power this and see. So you can see the VFD is powered and the power supplies are on. So we can turn that off. So they all go off. So the first stage of the project wiring is done. So comes on, goes off. So we have successfully distributed power to the whole system. So now let's power the drivers. So you can see the drivers are all powered. Now we're going to provide power to the controller itself. So like I said in the previous video, this is the power system, the system where it provides the system power to the controller right here. So you see that the middle is the ground, so we're just going to fit that there. and then the left side is 24 volts, so we're going to do that as well. We plug that back in place, and then we locate the 24 volt power supply, which is this one. Red goes to plus V, and then black goes to negative V. So now we have power here. Let's hold it down with some zip ties. Let's control this again. Plus V, and then minus for the ground. So at this point, we can plug the controller to see whether it comes on. So let us put the system on. You can see that the controller starts immediately because power has been provided to the controller. You can see there the controller is on. So we have power distributed to all the peripherals. So at this point now, we need to connect our motors to the controller. Let's do that. So connection for this is very straightforward. This is a driver, as you can see right here. We have since we are dealing with the signals right here, we're going to have post plus, post minus, direction plus, direction minus. These pins are directly labeled onto the driver. You have XP, which is for post plus. You have XP minus, which is for post minus. We have XD plus, which is for post direction plus, and you have XD minus, which is for post direction minus. So we're just going to connect it exactly like that. For that, we're just going to remove this pin here, this port, and then we now attach our cables. So you will see the black here is the The black here is post plus, so we can see right here is the first terminal. I'm just going to connect it there. The pink cable here is the post minus, so we're going to connect it to the other one. Then we have the blue here. This is the direction plus, so we just connect it there. Then we have the brown, which is the direction minus. So there you have it. We have the Y axis already connected. Just plug that in place. So as you can see right here, we already have all the motor, the drivers are connected to the controller. So we have them connected right there. We're now going to hold them in place with some zip ties. The wiring has got to be neat so that in case of any maintenance issue, we can easily find ourselves. So this is the basic wiring for this. So with this already we can control our CNC machine, but at this point we have limit switches on our system. So we have X, Y and Z limit switches to install. We're going to connect them to the inputs here, because you can see we have so many inputs. We have our probe for the Z height, and we have the limit switches to also connect on this system. Let's do that. Okay guys, so as you can see right here, I have my VFD hooked up to the controller itself. So this is the Fuling VFD. As you can see, my series, the series for the VFD that I currently have is the BD612. To set up this VFD is very easy. You just need to understand and read your datasheet properly. As you can see right here, I have this hooked up to A12 goes to the VSO pin of the DDCS shield. I have the RA, the first pin. This one is like a switch. RA pin goes to the out 1 or M3 of the breakout board, and I have my ACM and DCM all connected to common, so they all go to ground. If you don't hook it up like that, it will not work. So I just wanted to point that out. So hooking this up is very easy. But now after doing this, you need to go to the configuration software inside the controller itself, inside the parameters of the VFD itself, and configure some parameters. You need to tell the VFD to take signal from the shield If not, this terminal will be enabled and you'll be changing your speed, direction on the terminal, which is not appropriate for the CNC machine we have. Our CNC machine right here uses this controller, which has the ability of sending out PWM signals to the controller to the VFD and automatically control directly from the G code. So right here, we're just going to start the machine, then I'll show you how I did this. Let's power it up. You can see that. So you can see that this has come on. Okay, so I've already changed the parameters to enable this controller to send PWM signals to the VFD and control my spindle on the machine. So all I have to do now to power the VFD or to power my spindle is just to press the spindle on thing, which is F6. When I press here, you can get my spindle from the back. You can get that noise, the spindle is on. And my default speed is 23,000 RPM, so it goes close to 24,000. So I can stop this. And then I go back now into the settings and change some values to make my default speed to be 13,000 like it was initially. So let's go there. Just go there. I enter the default password. Then I enter. Then I go to parameter. And then I switch to 188, which is the spindle. Okay, so I can now go to this parameter. Okay, the default speed. I'll change the default speed to 13,000. So I just come here and then I press 13,000 and then I enter. Okay, then I move back to the main menu. It saves the values automatically. Then now you will see that my default spindle speed has gone to 13,000. Think when I will press the spindle start, you can see here that it ended at 456 Hertz. So this is the frequency corresponding to the speed that the spindle is actually giving out. Let's power this off. You see that works. So far we have the spindle working, we have the controller working, we have powered the drivers, we have wired our holding switch with the contactor and a circuit breaker and 2 push buttons. So the next thing we're going to do now to make this project be complete is to enclose it in the box and hook up the models and see how they move. And then from there now, we are going to configure the machine to make the steps per millimeters to match with the hardware that we have on the machine right there. So at this point, it's time for me to install the controller inside the box. For that, I got this box. I've already drilled some holes on the box, and I've also put some connectors already on top of the box. So at this point here, I'm going to carry my controller. I'm feeling the okay. So as you can see right here, this is the final project the outcome of the controller that we've been working on right now. What we've added a fan controller. So as you can see here, we have two fans. We have these two fans. One takes air into the box and the other one takes air out of the box, and it is controlled by this small controller unit. This controller unit measures the temperature within the box when it gets to a certain threshold before turning on the fans, and right now we have reached that threshold, so the fans are on. So for now we are done. This is the controller we have, and we're going to move on to the CNC machine and install it. Let's do it.